Hi everyone, hope everyone's doing well. Today I'll be presenting the project Bitcoin Core Conceptual Architecture Analysis on behalf of Group 11. Here are our group members, and we prepared an introduction video for those of you who like to get to know Bitcoin.
What is
Introduction. This paper introduces and provides an overview of Bitcoin, a decentralized digital currency that allows for peer-to-peer transactions without intermediaries. It operates through a network of computers that validate payments and add them to the blockchain, a public record of transactions within the Bitcoin system. The network is incentivized through a process called mining, where nodes complete to validate transactions and earn new Bitcoins. Despite facing challenges and criticisms, Bitcoin remains a popular and an innovative use case of Bitcoin technology. The paper aims to analyze the conceptual architecture of Bitcoin Core and outlines the derivation process, architectural style, subsystems, control and data flow, use case analysis, and lessons learned and limitations. The high-level architectural style is based on the peer-to-peer style. Derivation process. We researched Bitcoin's background online, then read Satoshi Nakamoto's journal paper to have a basic understanding of our project. We analyzed the function Bitcoin Core should be realized by 5 modules: blockchain, nodes, Bitcoin network, wallet program, and mining applications. After reading the developer guide, we split mining components into software and hardware, which are mentioned in the mining section. When discussing the architecture style, the P2P architecture style mentioned in Nakamoto's white book is confirmed early. Based on this, we found that the Bitcoin Core software should be layer style. We've considered the client-server style, but after understanding the client-server architecture, we found that the central server can be a single point of failure. If the server goes down, all the clients connect to it will lose their connection and cannot access the server's resources. Here are the major components: UI layer, user interface; wallet layer, wallet, mining pool server, and consensus. And the advantage of wallet layer: transaction validation and node. Bitcoin network layer, the mining software and mining hardware. And the advantage of Bitcoin network layer: Bitcoin network, and blockchain. Software development stages. The software was started by Satoshi Nakamoto in 2008 and first released in 2009. The first release version is called Bitcoin with version number 0.1.0 and only supported platform Windows. Starting from version 0.2.0, the software included Linux version. The software changed the name twice. Bitcoin Qt was a new name in 2011 version 0.5.0. In version 0.9.0, the software renamed to its current name. The version name is marked as major.minor. The development team will make a major release every 6 to 7 months and minor release from time to time to fix bugs. Once a new major version is published, 2 versions before the current major release will reach maintenance end, which means that the software will no longer be changed unless critical security bugs are found until end of life date. The implications for the division of responsibilities among participating developers. When designing the architecture of a software system, it is crucial to consider the division of responsibilities among developers, as how these parts will work ultimately impact the entire system. In the case of the Bitcoin network, there are different participating developers with varying responsibilities, including those who develop and maintain the network, verify transactions, ensure security, and manage user wallets. The network's decentralization and distribution of responsibilities are key features that make it a secure and reliable system for transferring value. Additionally, the absence of essential authority to make decisions by the development of the system means that the developer must collaborate and communicate effectively to ensure that the network remains secure and functioning properly. Open source development and a consensus process involving network participants are critical in achieving this. In summary, the division of responsibilities among participating developers in the software system is crucial and is essential to work collaboratively to ensure that the system remains secure and reliable. Thank you. I'm going to pass on to the next person.
And data flow in the Bitcoin network. The Bitcoin network relates on the two types of flows to function: data flows and control flows. Data flow refer to the process of generating and transferring new information, such as when a Bitcoin user creates a new transaction. This transaction is broadcast to the entire network and eventually reaches a node that runs the Bitcoin core. The node's preferred checks to ensure the transaction is valid before adding it to the list of unconfirmed transactions waiting to be included in a block. And control flows refer to the process of the receiving and processing information, such as when the Bitcoin core is started. The UI receives the user's input, which issues instructions to the wallet module. Once initialized, the Bitcoin core enters even loop and waits for incoming messages. User input and other events and other events. When new transaction is received, it is passed to a validation module that checks its validity and controls it to be added to the memory pool of the unconfirmed transactions. And the next one is concurrency. Concurrency is pertain to the simultaneous execution of self-contained and potentially interactive computer units or constitute which constitute the breakdown of program, algorithm, or problem in Bitcoin Core. Concurrency plays an essential role that allows multiple nodes to work in a parallel to validate transaction, add a new block to the chain, and maintain the integrity of a blockchain since Bitcoin is a peer-to-peer based. If there is no concurrency between nodes or cannot work together to handle different tasks on the same time, the CPU computing power of each peer will not be able to work together, and the Bitcoin transactions will not be complete, and the Bitcoin security will not be ensured. This is the second diagram of our first use case. It illustrates the interaction of those components when one user sends Bitcoin to another and how the data flows. The sender requires to obtain the Bitcoin address from the receiver, then launches a wallet program to create a transaction and enters the necessary information. The wallet program will verify if there is enough funds by checking the blockchain. Once confirmed, the wallet program creates a digital signature and then broadcasts it to the Bitcoin network. The network then broadcasts the transaction to each to let them confirm it. This step repeats until all the nodes finish confirmation. Finally, the transaction will be added to the blockchain as a new block, and the blockchain can be checked by the receiver through the wallet. And here's the second use case. This diagram shows the process of solo mining. Individual miners are mining software to pull Bitcoin periodically for a new transaction. The new transaction and the public key for the Coinbase transaction are returned to the mining software, which constructs the block with a block header and the difficulty setting to the sent to the mining hardware, known as ASIC. The ASIC finds the value between the target threshold. If the ASIP cannot find the value, it requires an update block header from the mining software. If a hash value is found below the threshold, the mining software combines the block header with the block to create the complete block and sends it to the Bitcoin for broadcast to the network and added to the blockchain. So the next conclusion. The paper discussed the interactions between the components and the modules and the evolution of the system, architecture, style, and subsystems, concurrency, and the use case analysis. The paper also highlights the lessons that can be learned from the conceptual architecture of Bitcoin. Overview: Bitcoin is an innovative and complex system with the potential to revolutionize financial transactions. The last one is lessons learned. Open source software development is crucial. It's the first lesson that I learned. So over 800 developers have contributed to the Bitcoin Core project on GitHub. The second lesson we learned from the Bitcoin Core is that decentralization is a key component of any system that aims to be resilient and secure. And thank you so much. This is our presentation. Thank you.